Hello everyone, my name is Sena Ahammed, a final year engineering student from Maharaja Institute of Technology, Mysore. With me, I have my teammates, Sreyas P, Raksha K.M, and Preetham H.N. We have selected the topic of Explainable Deep Learning Model for COVID-19 Diagnosis for our final year project. And we are doing this project under the guidance of our research scholar in our department, Ikechukwu, Agughasi. Next. In this presentation, we are going to discuss about the problem statement we have, the objectives we have accumulated, the system designs we have prepared, and also the literature served. Next. As we all know, COVID started from Wuhan, which was thought of just as a pneumonia, but then which was later discovered to be a deadly virus called as COVID-19. And then as and when the days increase, on the 23rd of January, Wuhan was put under quarantine or lockdown, and WHO declared it as a pandemic. And then on the 19th of March, there were 10,000 deaths. On the 10th of April, 2020, there were around 100,000 deaths. This kept on increasing. To this date, we have over 200 million cases worldwide and more than 4 million deaths worldwide again. On our way, there were some drugs which were actually approved by the government, which can be used as not a cure, but as a relief for the patients, which was remdesivir. But nothing stopped the war spreading and rapid increase in the number of patients of COVID. The death toll also kept on increasing until today. Next. So where do we stand now? Across the world, we have over 37 crore 39 lakhs 86,644 cases, which was actually a stat of the past week. And then we have around 56 lakhs 78,186 deaths which were reported. And there were around 29 crores 54 lakhs and 51,280 cases which actually recovered. In India, we have around 4.11 crore cases and a death toll of 4.94 lakhs. So from these stats, we can understand that COVID-19 is not just another disease which comes and goes, but this is something which has affected a lot of people, which has caused a number of deaths, millions of deaths across the globe. This has actually changed our lifestyle. See, for us, for the reason we are doing this presentation online is just another proof of how our lifestyle has changed because of COVID. Next. So COVID-19 started from Wuhan, but by now it has mutated a lot. There are a lot of variants which the COVID-19 produced. So on the 18th of December 2020, an alpha variant of this COVID was discovered in United Kingdom. And then on the 14th of January 2021, a beta variant was found in South Africa, and then a gamma variant in Brazil on the 15th of January. And then we had Delta in India on the 26th of May 2021. And presently we are facing Omicron, which was originated from South Africa on the 26th of November 2021. So this is not all there is. Actually, if we are not careful enough, if we are not precautious enough, these variants are going to increase day by day. As of now, we are actually facing a new threat, a new variant, which is nothing but the Neocov. Next. So Neocov is a new variant of the COVID-19, which is actually in the rising. People have started getting this version of the virus as well. So we have to be careful. So we are looking for something which we can do, which will help treat the patients, or which will actually help people understand who is affected by COVID-19 and who is not. Next. So the problem statement we have selected is that to diagnose COVID-19 or to detect COVID-19, we are not going for the traditional use or the RT-PCR or the RAT. This is not what we are going with. We are actually collecting chest X-ray images and CT scan images, and then we are going to process them using some deep CNN models, and then we'll make it classify chest X-ray images whether a patient is having COVID or whether he is not. So RT-PCR is used as a reference method for the detection of COVID-19 patients. However, the technique is manual, complicated, laborious, and time-consuming with a positive rate of only 63%. So it is not that reliable. Now, a significant shortage of its supply, which leads to the delay in the disease prevention efforts, is also a major fault which we are facing now. It is not as easy as we think it is. Just because the government is providing that free for us, it doesn't mean that it is cheap. It is very expensive, and the equipments required to do this particular test is also not that easy to come by. So the other diagnostic methods of the COVID-19 includes clinical symptoms analysis, epidemiology history, and positive radiography images, computed tomography, CT, chest radiography, CXR, as well as positive pathology testing. So because of this problem we are facing now, we are actually trying to come up with a deep convolutional neural network model, which will help in the rapid and accurate detection of COVID-19 patients and help us prevent the further spreading, or at least help us prevent a death of 1 or 2 people. Next, I hand over it to Sreyas. Sorry, Raksha is going to explain the objectives now.
The objectives of our project are to study various approaches used to detect COVID-19 that might be chest X-ray, CT scan, which we consider as the main effective methods. Then the methods used are to study the use of pre-trained model and transfer learning approaches for lung segmentation. And we have classified the chest X-ray from CT scan images into subtypes like positive and negative using deep convolution neural network. The fourth objective was CDSS, that is Clinical Decision Support System, to detect COVID-19 from CT scan images and chest X-ray. Next, I request Preetham to explain further.
Okay, here I'm going to explain about the existing system which we already have. First, we have a PCR test. Actually, we had two kind of tests which were found in the early days. One is RT-PCR and another one is RAT. RT-PCR is also known as reverse transcriptase polymerase chain reaction. How this process works is a sample from inside the back of the throat and nose is taken using a swab. It will be kind of uncomfortable, for being frankly. For children under 13 years, there is no need to give nasal swab sample. After this, the swab is sealed and sent to the lab. In lab, they extract the genetic material from the sample. They use special chemicals and enzymes and a PCR machine called as thermal cycler. And later they run the test and get samples, deliver the result to the patients. Usually RT-PCR test results comes around 24 to 36 hours. Next, we have RAT, which is also called as a rapid antigen test. The RAT comes in handy while detecting patients who are quite symptomatic. Here also the same, they'll collect the sample from nose and throat. Though the result can be revealed within 30 minutes, this test is not considered as an accurate test. Next, we have a serology test, also known as antibody test. Serology test is a screening test for COVID-19 antibody in your blood. It tells if you were previously infected with the virus that causes COVID-19. Anyways, that will not help you to detect that virus or which is present currently in your body. It is done by drawing your blood from the sample. Whereas result might come like within 1 day or. After this, in last we have image test, where we have MRI, ultrasound, and CT scans. MRI uses radio waves to give the result, and ultrasound use sound wave to create an image from it, and CT scan use X-rays. Next proposed system is going to be explained by my friend Sreyas.
Yes, thank you, Preetham. As Preetham explained, currently we are using two main methods that are RT-PCR and rapid antigen test. Yes, RT-PCR having an accuracy nearly 80 to 90 or 95, though it is there, we cannot detect the layer by layer prediction of how the COVID infected the lungs. Whereas in rat, having very least accuracy, it is mainly used to detect the COVID-19 as soon as possible by few RAT kits. And now our proposed system is detecting the COVID-19 or diagnosing the COVID-19 using CT scan images as well as or uh, chest X-ray images. Yeah, as you can see in the left side of the slide, we can see the flow chart. Here the CT scan images as well as X-ray images are taken as input, and these images are locally featured extraction, like lower bits perception, where the image is segmented and the lower bits are extracted, and it is again undergone to global feature extraction. Combining these two featuring, we are getting an perfect image to detect whether the person infected is COVID-19 or not with the help of pre-trained model. You can see the right side image. In this, an CXR is given as input, where it is undergone pre-processing. Pre-processing means the image is undergone pixel brightening transformation or brightness correction or geometric transformation, like Fourier transformation, image restoration, and image filtering, segmentation, etc., etc. And it is undergone. It is given to an input to an CNN model called VGG19, and from VGG19 we are getting to the frontal or lateral prediction, from where it is obtained whether the person is infected by COVID-19 or not. We can also use UNet, which is an very good model to detect or to predict uh, the image based on its bits and based on its segmented area which is infected. Uh, in UNIT, we are going to enhance the image according to their grayscales, and the image is augmented also. And then from UNIT, we can also predict whether the person is positive or negative. Yeah, next image. Yeah, we have n number of data sets, and these data sets are into data preparation, like we do augmentation, we image enhancement, we enclave it, and we do image resizing accordingly. In augmentation, we do horizontal flip, width shift, and height shift. And image enhancement, the image is undergone histogram equalization to get enhanced image, like spectrum uh, it is undergone image spectrum analysis and gray and cyan scale imaging. Then it is normalized and feature highlighted. And the obtained enhanced image is undergone with CNN models. It is where there we have pre-trained models like VGG16, VGG19, MobileNet, UNet, uh, etc., etc. And it is undergone through these model. We get whether the we get trained model, and from there we can easily identify the person is infected or not. We also undergone accuracy prediction and compilation time sensitivity prediction and precision. We check precision and F1 scores. The main agenda of doing these things is we came to know that what is actually happening in our project. So if the accuracy is less or uh, accuracy need to be improved, then we can further improve our model, or we can improve our procedures and all. So for the main reason of doing performance evaluation is this. And finally, we will be getting the classification outcome, like whether it is COVID-19 or healthy lungs. The next image. Yeah, actually, we'll be having mainly 6 models, pre-trained models, convolutional neural network models that are VGG16, Inception V3, and ResNet 50, DenseNet 121, and DenseNet 201. The CT scan image is getting into the VGG16 and other model, which is mainly used to predict accurately whether the person is infected or not. Next. Yeah, we had read more than 8 papers for our literature survey, and the paper will be explained by our teammates further. Sena will be continuing. follow.
So as my friend Sreyas just said, for our particular project, we have gone through 8 papers. We have tried to understand how they have done it, why they have done it, and the different algorithms they have used, and all sorts of techniques they have used in implementing their projects. So the first paper we have selected for our literature survey is titled, "Can AI help in screening viral and COVID-19 pneumonia?" So this paper was written by Mohammed E.H. Chowdhury and a few of his helpers. This was published in the journal IEEE Access in the year 2020. So this paper mainly focuses on classifying a chest X-ray image either into normal, viral pneumonia, or else COVID. So this is done by first collecting the data set. Here they have taken chest X-ray images which are publicly available in different places. Actually, in different places, they have put it into one place so that our model can come up with a better accuracy and better result when compared to the other projects or other paperworks that have been done. Here the thing is, in majority of the projects which is related to detecting COVID-19 from chest X-ray images, the data set they have used is very small, or the number of chest X-ray images or the number of inputs they have used is very less. So here, to overcome that limitation, what they have done is they have collected data sets from various sources. In this paper, they have used around 1,500 chest X-ray images, which are then classified into 3 categories. As I just said, normal chest X-ray image, viral pneumonia, or else COVID-19. So this data set is what is being used to train our model so that our model can come up with a better prediction. So in this paper, they have actually used, the data set or the images go through all sorts of pre-processing which are required by our machine learning model. And then in the machine learning model, we are actually going through 8 CNN models. We are using this data set to train all our 8 models with and without image augmentation. And after all the training we have done, we go through the accuracy of each of these modules. And then the authors actually decided which of these 8 CNN models are going to be the best to actually predict whether a patient is having COVID or not. They have used a number of CNN models such as ChexNet, ResNet, VGG16, VGG19, and then DenseNet, etc. So from their observation, what they have come up with is that without image augmentation, chest XNet is going to put out the best accuracy among all the CNN models. It is also observed that with a larger data set, DenseNet is also providing us with a better accuracy. So we move on to the next paper now. Actually, in the previous paper, the main drawback was that all the images or all the chest X-ray images, all the data set they have acquired was publicly available. And it is actually very difficult to get by a data set which is clinically approved so that all our diagnosis is 100% correct. It is a little difficult to do that. And that is the reason why they have gone with publicly available data sets, which again cannot be trusted 100%. Now, in a second paper, which was written by D. Arias Garzon and G. A. Alzate Grisales, and it is titled The COVID-19 Detection in X-ray Images Using CNN or Convolutional Neural Network. This was published in the journal Elsewhere in the year 2021. In this paper, they have shifted their focus. They have shifted their focus to the pre-processing part. They believe that once an image is pre-processed efficiently, then the result which comes by those pre-processed data set is going to be much more efficient than when it is pre-processed using a different data set. So in here, for the pre-processing, they have used a network of filters which is going to help them understand the image better, which is going to help the CNN models understand the image better. They have also used UNet for image segmentation to concentrate on the image region, which is going to be of use to us. They have used the UNet to do the image pre-processing, and then they have used CNN models such as VGG16 and VGG19 for the processing. And then they have used these models to train the data, to train the machine learning model. and then come up with the accuracy. The accuracy achieved by this paper is around 98%. And here again, the data set is not as large as one would want, but even then, I think they have used across 500 chest X-ray images to do this particular project. And next, I give on to Preetham, Raksha.
Third paper which we went through is COVID-19 detection using deep learning algorithm on chest X-ray images by the author Shamima Akhtar, F.M. Javed Mehendi, Shamrat, Sawan Chakraborty, Asif Karim, and Sami Azam by the journal MDPI in the year 2021. The paper provides an overview of the purpose of an automated deep learning based classification model based on the CNN, that is convolution neural network, that demonstrate the rapid detection rate of COVID-19. And initially they used 11 existing CNN models. In that they came up that MobileNet V2 was selected for the further modified to get high accuracy of 98% in classification COVID-19 and the chest X-ray. Then the second tool they took is VGG19 and ResNet 101 with accuracy of 95. And chest X-ray and CT scan should be preferred only when RT-PCR tests are not available. Then the algorithm uses BMOCRNN, and they came up with that modified net V2 modified is proposed in higher accuracy rate in the short time. The pre-trained CNN models and compared their performance to the modified mobile network V2 in order to get the highest performance of COVID-19 from 52,000 COVID-19 images. Due to the imbalanced data, it is difficult to determine which classified performance is better to detect COVID-19. There are only marginal difference between the result. So finally, they understood that modified mobile V2 gives the most optimal result with the highest accuracy and the lowest compilation time. They came with the conclusion that deep learning is used to detect COVID-19 from chest X-ray images. The main drawback of this paper is the lack of proper feature extraction process from image data. Moving on to the fourth paper. The title of the paper is Transfer Learning to Detect COVID-19 Automatically from X-ray Images Using Convolution Neural Network. The authors are Munder Mohammad Tarish, Nigob Zuhu, Talal Ahmad Ali, Azad Shakir Ahmad, and Modi Lalal Muttar by the journal Hind Dawai in the year 2021. This paper explained the author mentioned the poor performance of MobileNet V2 in distinguish with the COVID-19 from other pneumonia cases when the dataset included only bacterial pneumonia cases, thus attempted to distinguish COVID-19 from the neural network. The main aim of this paper is to reduce both false and positive rate of such possible. In this, they said that transfer learning technique was applied using ImageNet data to resolve the problems of data and time. Due to the imbalanced data, it is difficult to determine which classified performance better to detect COVID-19, and the data set they use is CXR. There are only minute difference between the result. Then they said that MobileNet and VGG16 got the highest accuracy. Thus, the study of multi-cases classification of CXR image with AI technique, the purpose method achieved an accuracy of 97.94% with the tool NET 2001 and 97.94% for ChestNet without the image augmentation. Then the conclusion of this paper was the pre-trained deep learning network were applied to define best deep learning technique. The VGG16 and MobileNet were superior from the result, and the main drawback was the large amount of data was needed from the patient to differentiate which is the best tool. Now I request my teammate to continue the papers.
Yeah. The next paper is deep learning based detection of COVID-19 using lung ultrasound imagery. It was proposed by Julia Diaz Escobar, Nelson E. Ordonez Gile, and Salvador Varela Reyes. It was published by the journal called Plus One and in year 2021. The main objective of this is to evaluate and compare the performance of deep learning techniques for detecting COVID-19 infection from lung ultrasound image. It was to implement and evaluate the use of IV3, ResNet 50, VGG19, and exception based deep learning model for COVID-19 screening in LOS imaging. It also shows that deep learning based models improve the COVID-19 pneumonia and healthy classification performances. Proposed models are capable of providing the basis for further development of LOS imaging based on COVID-19 computer assisted screening tool. The conclusion from this paper was that the main contribute in this is to bring the focus on deep learning tech for computer assisted analysis of lung pathology based on LOS imaging, a research area that has not been widely explored and that has different advantages for CT or X-ray. And main theme was to develop an AI-based COVID-19 screening tool that uses LOS imaging as an alternative where there is limited access to CT or X-ray equipments. This fact becomes crucial in rural areas and developing countries where wide access to ultrasound devices might be more feasible because its portability and low cost features and compared to CT scan and X-ray. Moving on to the next paper, we have deep learning algorithm for COVID-19 classifying using chest X-ray images. And the authors were Sharmila Vijay and Jamie Florinable. It was published by the journal called Hindavi and in year 2021. The main theme of this is that the proposed CNN model consists of 8 convolutional layers where 4 are max pooling layers and 4 are fully connected layers for extracting image features. DCGAN is an effective technique for generating large data sets where CXR images were utilized for gathering the visual indexes of COVID-19 diseases. By combining the DCGAN and CNN, learning models have exhibited versatile performance in COVID-19 classification. From this, what they concluded from this paper is that after numerous studies, they found that the average CNN classification performance is less in COVID-19 detection with small and large publicly available data sets. And findings confirm that the findings done by these people confirm that the efficiency of the proposed DCGN and CNN has a powerful visualization and high learning ability that helps to detect the different classes of normal pneumonia, COVID pneumonia, and pneumonia. Next, I'd like to hand over to my friend to explain the next paper.
Yeah, the seventh paper that we went through is COVID-19 pneumonia on chest X-ray performance of a deep learning based computer aided detection. The authors of this paper are Yu Jin Hong, Hee Byung Kim, and Jim Young Kim, Jae Kwang Lim, Ju Gangnam Hyo. Sorry. It is published in the journal Plus One in the year 2021. Yeah, in this paper, they are mainly concentrating on the chest X-ray images for the diagnosis, and they are going under computer-aided detection system for COVID-19 detection. Yeah, and they're using deep learning based CAD, that is computer aided detection. They use commercialized deep learning based CAD like Lunit Insight CRX and Lunit Inc. Seol for evaluating the CXRs. The CAD was designed to detect pulmonary nodules or masses in pulmonary influx and pneumonias on CXRs. This CAD was initially trained using 54,221 normal CXRs and 35,613 abnormal CXRs to train their model. And in this CAD, they provide probability score between 0 to 100% for the presence of abnormalities and of each CXRs. A heat map override CXRs also. They're also using heat light override CXRs. And the main conclusion, the conclusion of this paper is, uh, since the CAD is used, they are having many limitations, and since the commercialized clinically available deep learning based CAD exhibits similar performance using CAD, the AUC they are getting is 0.714 and 0.790, and the accuracy for this thing is nearly 98% they're getting. And in the next paper, the next paper is detecting coronavirus from chest X-ray using transfer learning. The author are Abir Badwa and Khalid Elnzer. It is published in the journal MDPI in the year 2021. And in this paper, they are mainly using chest X-ray, and they are classifying the X-rays into COVID pneumonic X-rays and normal X-rays. Yeah, they're finding they collected the data sets around 5,000 image of normal lungs and 5,000 image of pneumonic lungs and 4,420 images, around 5,000 of COVID-19 images. Total, they're training their model with 15,000 images. They're also doing data pre-processing and augmentation to get the accuracy, to get high accuracy. And the pre-trained model they're using are VGG16, VGG19, and DenseNet 201. They're using the models available in TensorFlow and Keras library. Yeah. Then majorly they're doing implementing the DenseNet, and they're doing average pooling in 4x4 pattern, and they're flattening the image and fully connected network dimension of 128 and fully converted network dimension of 64. And their dropout is 0.4 fully connected softmax activations. And they're binary classifying normal and COVID-19 and multi-classifying as normal, pneumonia and COVID-19 as classification. The performance matrix is around the accuracy of 99.30 in the loss of 0.021 in the epoch 15 classification. The main conclusion of this paper is the prediction of COVID-19 using chest X-ray mainly, and using chest X-ray to detect virus faster. And they're using around 5,000 data sets, so they're expecting the accuracy nearly 99.62. And yeah, it is one of the nice paper we read. Yeah, next slide. Yeah, after reading the 8 papers and other papers also, our survey findings are we should select appropriate data sets, because the data sets plays a major role in the accuracy of our model and accuracy of our project too. So selecting a proper data sets plays a major role in this. So for that we are selecting the data set from the website named physionet.org. Yeah, it is expensive. Though it is expensive, the datasets from this website are clinically approved and verified from many doctors and many experts. So these datasets are most efficient physio.net. And yeah, Of course, data preparation also matters. Enhancing the data sets and improving the quality also matters. So we are going through certain methods from these papers, and we are using CNN models, like 8 CNN models, as we discussed previously. And we undergo performance evaluation in every steps and every finishing stage, so that we can improve our uh, performance of our model. And we select few algorithms which is effectively using from deep learning and transfer learning as well as, and outcome is classified as healthy or COVID lines. Next one. As we discussed, PhysioNet is one of the best clinically approved datasets, and that we are going to involve in our program or in our models and in our projects. And mainly the datasets used are CXRs and CT scans. So this is one of the best method as per we surveyed. And the algorithm uses conventional neural networks like 18 models. And the methodology is step-by-step approaches like deep convolutional neural networks, and typically perform better with large datasets than a smaller one. After great consideration and conclusion, we have gone through many papers, and from these papers, we'll be trying to train our model as well as our project with great accuracy and come with small precisions. So that's all our project is. Next slide. Thank you everyone for your patience, and